The graph of the function f is shown in the figure to the right-ish. For which of the following values of x is f prime of x negative and decreasing? So if f prime of x is negative, that means it is going down and to the right. It has a negative slope. So this part means negative slope. When it's decreasing, if the slope is decreasing, that implies concave down. When the rate of change is decreasing, concave down, if you remember that from AP pre-calculus. So I need something that has a negative slope and is also concave down. So A has a negative slope and appears to be concave down. B, nothing. C is positive and concave down. D is negative and concave down. And A is positive and concave up. Oh, no, I take it back. D is not concave down. D is an inflection point. So the only guy that I can choose is A, because A is the only spot that is concave down and also decreasing. So kind of a bizarre problem. Boy, does that look awful. But I did it. Given the graph of f prime of x, determine which of the following statements must be true. All right, so this is f prime of x, not f of x. So let's look at these three options. Option number one says relative minimum at wherever. Well, in order for there to be a relative minimum, that means our derivative, right, must go from negative to positive. So if at negative 7/4, which appears to be u, I'm going from negative to positive. So that's a 0. This is negative, this is positive, so this is true. If f of x is concave down at negative 2, 2, that means that the rate of change, or the slope, if it's concave down, the slope is decreasing. At negative 2, 2. So here's negative 2. There is no negative 2, 2. Oh, it's talking about this guy. It's talking about the interval. It's talking about the interval negative 2, 2. Well, my slope this whole way is positive, getting shallow, getting more shallow, getting more shallow, getting more shallow, getting more shallow, negative, bigger negative, steeper negative, steeper negative, steeper negative, steeper negative. So yeah, since my rate of change is decreasing the whole time, we could say 2 is true. F of x is differentiable on the interval negative 3 and 3. That is not true because we have a sharp edge right here and a sharp edge right here, which means it's not going to be differential at those two areas. So the only ones that work are 1 and 2. The graph of the derivative of function f is shown below. At what value of x does function f have a relative maximum? Okay, so this is the derivative. A relative maximum occurs when your derivative goes from positive to negative, because that would represent a relative maximum. What I need to do first is find out the critical points for that to happen. So since this is the derivative, I care about where I get a 0, which is negative 2 and at 1. So I can make a sign chart of f prime of x based off of that information. At negative 2 and at positive 1. To the left of negative 2, I'm in positive land. And at negative 2 to 1, I'm below the x-axis. And from 1 on, I'm also below the x-axis. So right here at negative 2, I go from positive increasing to negative decreasing, which means I have a relative maximum at that guy right there, negative 2. So that's how you do it. The graph shown below shows the derivative f prime of x of the function f of x. At which values does function f have a point of an inflection? Well, a point of inflection exists when f double prime of x equals 0. Now, what that would mean in this context is that the derivative of this function is 0, which means I want a slope of 0 or a flat slope. Where does that happen? Well, it happens at B where it changes from positive to negative, and it happens at D where it changes from negative to positive and nowhere else. So B and D are going to have a horizontal slope, which means the derivative of the derivative is 0 at B and D. Interesting problem. I like it.